Hello, in this video we are going to talk about cylinders and quadratic surfaces. To identify cylinders and quadratic surfaces or to sketch them, we need curves called traces or cross-sections. Traces or cross-sections of a surface are curves of intersection of the surface with the planes parallel to the coordinate planes. As you know, we have three coordinate planes: xz plane with equation y equals 0, yz plane with x equals 0, and xy plane with z equals 0. Now, let's talk about cylinders. A cylinder is a surface that consists of all lines that are parallel to a given line and pass through a given curve. Now, to understand cylinders better, let's have a look at this example. It says, sketch the surface x squared plus y squared equals 1. Now, from two dimensions, we are familiar with the equation x squared plus y squared equals 1. It represents a circle with radius 1. But in 3 dimensions, this equation represents this cylinder. Now, how do we obtain this picture? Now, in the equation, the variable z is missing. So, which means that for every z, we are going to have a circle with radius 1. And then, we choose ourselves the z-axis and we draw lines parallel to the z-axis passing through the circle x squared plus y squared equals 1. And the final picture, it's going to be this infinite cylinder. In this example, we want to sketch the surface z equals y squared. If you check the equation, you will see that the variable x is missing. Now, in the yz plane, this equation represents a parabola that passes through the origin. And then we draw lines parallel to the x-axis, which pass through that parabola z equals y squared to obtain this final surface. And then the cross-sections parallel to the yz plane are the parabolas z equals y squared. Now, a quadratic surface is the graph of a second-degree equation in 3 variables x, y, and z, whose most general form is as follows. So, if you check this equation, you are going to see the squares of variables, you are going to see variables multiplied with each other, and you are going to see the terms with degree 1. Now, in this video, we are going to talk about 6 quadratic surfaces: ellipsoid, elliptic paraboloid, cone, hyperboloid of 1 sheet, hyperboloid of 2 sheets, and hyperbolic paraboloid. Okay, let's start with the ellipsoid. Now, ellipsoid is a quadratic surface whose equation is of the following form: x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. And the graph of this quadratic surfaces is this. Now, let's have a look at the traces of an ellipsoid. Now, to find the traces on the xy plane, I need to intersect my ellipsoid with a plane parallel to the xy plane, which is a plane of the form z equals k. So, it means that we are going to substitute k for z in the general form of the ellipsoid equation. And from here, we have x squared over a squared plus y squared over b squared is equal to 1 minus k squared over c squared. Now, we observe that if k is between negative c and c, then 1 minus k squared over c squared is strictly positive, and then therefore traces are ellipses. Now, if k is equal to c or negative c, then 1 minus k squared over c squared is equal to 0, and therefore traces are 2 points, 0, 0, c, and 0, 0, and negative c, because when 1 minus k squared over c squared is equal to 0, our equation becomes x squared over a squared plus y squared over b squared equals 0, and the only solution of this equation is when x and y are both equal to 0. So the traces are 2 points in this case. And if k is more than c or k is less than negative c, then there are no traces. Now, we can confirm this investigation by looking at the picture. Now, these top and bottom points are z equals c and z equals negative c. Now, if I choose a plane z equals k, where k is less than c and more than negative c, I'm going to intersect with this object, and the intersection is going to be an ellipse. If z is equal to negative c or z is equal to c, then I'm going to only intersect with this ellipsoid at this top and bottom point, which means the intersection is going to be 0, 0, c or 0, 0, negative c. And if my planes are z equals k, where k is less than negative c or more than c, and I will not intersect at all with this ellipsoid, so there will be no traces. If you check the traces parallel to other coordinate planes, you are going to get the same conclusion. So the traces of ellipsoids are either ellipses or 2 points or no trace. Our next quadratic surface is elliptic paraboloid. The general equation of the elliptic paraboloid is of the form z over c equals x squared over a squared plus y squared over b squared. And the graph of this quadratic surface is as shown in the picture. Now, let's investigate the traces of an elliptic paraboloid. So, I'm going to check the first traces along the xy plane. So, we are going to substitute k for z, then the paraboloid, elliptic paraboloid equation will give us x squared over a squared plus y squared over b squared is equal to k over c. Now, we are here not assuming anything about the value of c or k. So this represents an ellipse. Of course, if k and c have opposite signs, then there is no intersection. So this equation represents an ellipse if k and c have the same sign. Otherwise, there is no trace. So that's what happens on the planes parallel to the xy plane. Now, let's check yz plane or xz plane. So, which means x equals k or y equals k. Now, these traces are going to be as follows. A squared over a squared plus y squared over b squared is equal to z over c. So, this represents a parabola. Now, if I check the trace along the plane y equals k, I'm going to have x squared over a squared plus a squared over b squared equals z over c. This is again a parabola. So, the traces of an elliptical paraboloid are ellipses or parabolas, or there are no traces. Our next quadratic surface is the cone. The general form of the cone equation is x squared over c squared equals x squared over a squared plus y squared over b squared. And the sketch of this equation is as shown in the picture. Now, let's have a look at the traces of this cone. The traces along the xy plane, which means that I'm going to intersect the cone with the plane z equals k. So, the equation of the intersection, it's going to be x squared over a squared plus y squared over b squared. It's going to be equal to k squared over c squared. Now, we have, from this point on, we have two possibilities. If k is equal to 0, then the equation it's going to be of the form x squared over a squared plus y squared over b squared equals 0. And the only solution of this equation is when x and y are equal to 0 and 0. So, the trace, in this case, is the point 0, 0, and 0. Now, the next case, if k is not equal to 0, then the intersection is going to be an ellipse. So, now let's check the other traces along the xz plane, meaning that I'm going to intersect the cone by the plane y equals k. We will have x squared over a squared plus k squared over b squared is equal to z squared over c squared. Now, let's rewrite this as follows. Z squared over c squared minus x squared over a squared is equal to k squared over b squared. Now, again, we have two possibilities. If k is equal to 0, then the intersection equation becomes z squared over c squared minus x squared over a squared is equal to 0, from which we get z over c. It is either equal to x over a or z over c. It's equal to negative x over a. And these are two lines. So, in case k is equal to 0, the trace along the xz planes are two lines. And in case k is different than 0, then the intersection equation it's just a hyperbola. So, and the same thing it's going to happen along the YZ plane. So if I intersect this cone with the planes in the form of x equals k, I'm going to have the same traces. So overall, the traces of cone are ellipses or a point 0, 0, 0, or two lines, or a hyperbola. Let's have a look at hyperboloid of one sheet. The equation of hyperboloid of one sheet is in the form of x squared over a squared plus y squared over b squared minus z squared over c squared is equal to 1. And the graph of hyperboloid of one sheet is as shown in this picture. Let's also have a look at the traces of this quadratic surface. So first, the traces along the xy plane, which means on the planes z equals k. So x squared over a squared plus y squared over b squared minus k squared over c squared equals 1. Now, by rewriting this, I'm going to have x squared over a squared plus y squared over b squared is equal to 1 plus k squared over c squared. And whatever the value of k is, this is going to represent always an ellipse. So, the traces on the plane z equals k are ellipses. Now, YZ plane, the planes of the form x equals k, substitute k for x in the equation, k squared over a squared plus y squared over b squared minus z squared over c squared is equal to 1. From this we get y squared over b squared minus z squared over c squared is equal to 1 minus k squared over b squared. And for any value of k, this equation represents hyperbola. And if you check the traces along the xz plane, you have to substitute k for y, and by rewriting this intersection equation, we identify it as, again, a hyperbola for any value of k. So, the traces of an hyperboloid of one sheet are either ellipses or hyperbolas. Our next quadratic surface is hyperboloid of two sheets. The general form of the equation of hyperboloid of two sheets is as follows. It's negative x squared over a squared minus y squared over b squared plus z squared over c squared is equal to 1. And the graph of this equation is as shown in the picture. Now, let's have a look at the traces of this quadratic surface. Now, we start with the traces along the xy plane. We substitute k for z in the general form of the hyperboloid of two sheets equation. So that's the intersection on the plane z equals k. We rewrite it as follows. X squared over a squared plus y squared over b squared is equal to k squared over c squared minus 1. Now, if the k's are between negative c and c, then the number k squared over c squared, it's going to be less than 1. And therefore, the k squared minus c, the k squared over c squared minus 1 will be strictly less than 0. So the other side of the intersection equation, it's always positive. This means that there are no traces. Now, if k is c or negative c, then k squared over c squared minus 1, it's going to be 0. And the intersection equation will be x squared over a squared plus y squared over b squared equals 0, and whose only solution, it's x equals 0 and y equals 0. Therefore, traces are going to be the points 0, 0, c and 0, 0, negative c. Now, the last case, if the k's are less than negative c or more than c, then k squared over c squared, it's going to be strictly more than 1. So the number k squared over c squared minus 1, it's going to be strictly more than 0. So the traces are going to be ellipses. Now, we can confirm this investigation of traces by looking at the graph of hyperboloid of two sheets. If I choose planes between these 2 points, which are parallel to the xy plane, then there will be no intersection, which means there will be no trace, and this is going to be the case where the k's are between negative c and c, because those points here are c and negative c. Now, if I choose the planes z equals c or z equals negative c, the intersection, it's going to be just one point, either this point or that point, which are the points 0, 0, c and 0, 0, negative c. Now, if I choose planes z equals k, where k is less than negative c, I'm going to intersect with this part of the hyperboloid of two sheets, and the intersection is going to be an ellipse. And if I choose a k which is bigger than c, then z equals k will intersect with this part of the hyperboloid of two sheets, and the intersection is going to be, again, an ellipse. Now, let's also check the other traces along other coordinate planes. So let's have a look at the YZ plane. So I'm going to intersect the hyperboloid of two sheets with the plane x equals k. So negative k squared over a squared minus y squared over b squared plus z squared over c squared is equal to 1. If we rewrite this, we will have z squared over c squared minus y squared over b squared is equal to 1 plus k squared over a squared. And for any value of k, this is hyperbola. Last trace along the xz plane, which means we are going to intersect the quadratic surface with the plane y equals k. X squared over a squared negative minus k squared over b squared plus z squared over c squared is equal to 1. We write this as z squared over c squared minus x squared over a squared is equal to 1 plus k squared over b squared. Again, for any value of k, this intersection is going to represent a hyperbola. So, overall, the traces of hyperboloid of two sheets are either 2 points, or ellipses, or hyperbolas. Our last quadratic surface is hyperbolic paraboloid, whose general equation is in the form of z over c equals x squared over a squared minus y squared over b squared. And the graph of this equation looks as shown in the picture. Now, let's have a look at the traces of hyperbolic paraboloid. The intersection with the plane z equals k, we are going to have x squared over a squared minus y squared over b squared is equal to k over c. And for any value of k, this equation is going to represent a hyperbola. Now, traces along the yz planes. So, x equals k. K squared over a squared minus y squared over b squared is equal to z over c. And these equations for any value of k. And lastly, the traces along the xz plane. The x squared over a squared minus k squared over b squared is equal to z over c. And these are again parabola equations. So, the traces of hyperbolic paraboloid are either hyperbolas or parabolas. In this exercise, we want to reduce the quadratic equation into one of the standard forms and then identify it. So, I am going to first group the terms with x, y, and z in it. So, there is only one term with x in it, that's 4x squared. The terms with y in it are y squared and negative 4y. And the terms with z in it are 4z squared minus 24z. And then we have also the constant 36. So the equation is equal to 0. So I'm going to rewrite this one more time. I'm going to factor out the 4 from the terms which contains z. Now, 4x squared is going to stay as 4x squared, but to complete the terms, the two terms y squared and negative 4y into a parenthesis square, I need to add 4 to both sides of the equation. And to complete the two terms z squared minus 6z into a parenthesis squared, I need to add 9 inside the parenthesis, which is under 4. It will be as if I have added 36 to the left side of the equation. So I'm going to add also 36 to the right side of the equation. So let's rewrite our equation one more time after we had added these constants. I can complete the terms with y in it into parenthesis square of y minus 2. I can also complete the terms with z in it into the square of z minus 3, and then I subtract 36 from both sides of the equation, and our equation will be equal to 4. Then, by dividing both sides of the equation by 4, we will have x squared plus y minus 2 squared over 4 plus z minus 3 squared is equal to 1. Now, this equation is one of the standard forms of a quadratic surface, and that quadratic surface, it's an ellipsoid, because all variables are squared and added, and the sum is equal to 1.